Good day, everyone. My name is Alvin Santaole of Cabasal, and today I will be discussing all about manometers. First, we discuss the manometer's definition. A manometer measures the difference in air or liquid pressure by comparing it to an outside source, usually a sample of Earth's atmosphere. There are several types of manometers, the simplest being a piezometer tube, which is a single tube and the base that holds the liquid. More common manometers are U-shaped and have interconnected tubes. Manometers are used in atmospheric surveys, weather studies, gas analysis, and research of the atmospheres of other planets. Furthermore, they are usually made of glass or plastic, and while most are scored for measurement, some can measure changes digitally. The single tube manometer measures only the pressure of a liquid, since there is no alternate place to compare gases. A U-shaped manometer essentially pits two different gas pressures against one another and measures the strength of the captured gas. The free-flowing gas is usually air at the current atmospheric level. This is the most basic example of the manometer. Mechanics of manometers, or, in short, how they work. First, a liquid is placed in the tube, usually a responsive liquid, usually mercury, that is stable under pressure. One end of the U-tube is then filled with the gas to be measured, usually pumped in so the tube can be sealed behind it. The other end is left open for a natural pressure level. The liquid is then balanced in the lower section of the U, depending on the strength of the gas. The atmospheric pressure pushes down on the liquid, forcing it down and into the closed end of the tube. The gas, trapped in the sealed end, also pushes down, forcing the liquid back to the other side. Then, a measurement is taken to see how far the liquid in the sealed end has been pushed, either below the point of the liquid in the open end or above it. If the liquid is level, straight across in both tubes, then the gas is equal to outside air pressure. If the liquid rises above this level in the sealed end, then the air's pressure is heavier than the gas. If the gas is heavier than the air, it will push the liquid in the sealed end below the equal point. This is how it works. This is the figure. This is an example of a U-tube manometer. As you can see here, it consists of a U-shaped glass tube with one end open to the atmosphere, which is seen on the right side. Mercury at the bottom of the U. The mercury is the color black in the glass tube, and the gas to be measured in the other side of the U-tube. The gas is added, and the glass tube is sealed on the gas side, so the gas is trapped on one side of the mercury. The liquid mercury is equalized in two sides of the tube at atmospheric pressure. When the gas is added, it will exert pressure on the mercury on the other side. If the pressure of the gas is equal to atmospheric pressure, the mercury will remain at the same levels on both sides. That scenario isn't seen on any of these. If the gas is exerting more pressure on the mercury than on the sealed side, the difference between the two heights tells you how much higher the gas pressure is than the atmospheric pressure. It is seen at the open end, the one labeled H2. Adding the difference to the atmospheric pressure will give the gas pressure. If the gas is at a pressure below that of the atmosphere, then the mercury will be lower on the gas side, and the difference in height is subtracted from atmospheric pressure to get the gas pressure. Qualifications of manometers. Since Earth's atmosphere can change based on elevation and temperature, the difference must be computed to reach an average atmospheric pressure. Otherwise, the manometer will show slightly different results at different elevations, making precise studies impossible. So this basically means that when you're using a manometer, you have to take into account the elevation and the temperature of the environment you're in, because it will really affect the measurements you will have. Next up are types of manometers. The first type was the one shown earlier. It's the most common manometer, which is the U-tube manometer. It's shown here. It's the simplest type of manometer. It is used in the measurement of both liquid and gas pressures. Manometric fluid of known specific gravity is used, usually mercury, once again, and both legs have the same area. Both legs meaning the U glass tube. Mercury is generally used as fluid. For the second type, enlarged manometer. In this manometer, A2 is not negligible compared to A1. It has a float in the enlarged leg, which is utilized for indication or recording. The two legs can be changed for changing the measurement span. The third type is the well-type manometer. The well-type manometer is actually similar to U-type manometer, except that it doesn't really have a U-tube made of glass or plastic. Instead, the pressure is applied directly to the well. So you can see here, one leg is a simple tube, the other leg is a large well. For small displacement of liquid level in the well, there will be a large change in the height of the simple tube. Lastly, the inclined tube manometer. The inclined tube manometer is almost once again similar to the well-type manometer. The only difference being that its tube is inclined. It is a slant manometer basically. The angle of measuring leg is about 10 degrees, and inclination is done to improve the sensitivity. Doing this also increases the accuracy of the measurements. It is used to measure very small pressure differences. The inclination helps especially when you're measuring small pressures. That's it. Thank you for listening.